Hey guys, welcome to my channel iCode. I am Pallav and today we are going to discuss some of the very frequently asked interview questions on structs, classes and actors. Most of the iOS interviews start with the question structs versus class, and the answer to this question and the follow-up questions decide the direction of your interview. So today in this video we'll cover almost all the questions related to the structs and classes, and we'll discuss them in such a way that you would be able to answer all the questions around them later. But before jumping on to the questions, let's very quickly go through the basics of structs, classes and actors so that then the questions make sense. This will be really quick and I'll try to wrap it up in less than 2 minutes. So let's get started. Let's start with structs. So struct is something that we use for creating our own data types, be it employee, student, item or whatever. We use the keyword struct and create our custom data type. Now comes the point that what are the properties of structs. So structs are value type. We all know that when we take an instance of a struct and assign it to another variable, it is actually copied. So sharing of that reference kind of thing is not there with a struct and they are value type. The second thing is that structs can define properties and functions which we use for our implementation. So this is even needless to mention. And the first important point is that structs can be extended. So by this, I do not mean that they have inheritance associated with them. By extension, I mean that we can write extensions to struct. So we can add some functionality to an existing struct by writing an extension to it. It does not mean that structs can be extended in the form of inheritance. It just means that we can write extensions to existing structs. For example, array, strings, and all those. The next thing is that they can conform to protocols. So we can write any protocol and can make our struct conform to it. This is very obvious. Structs can be used with generics and we can define subscripts to them. So this is really common. Array is a classic example of this. Now let's move on to the next thing, that is classes. Now classes have all these things that we just discussed for structs, but apart from them, classes have some additional functionalities, and the first one is that they are reference type. So when we assign an instance of a class to some other variable, both the variables actually point to the same memory location. That is what reference type is. The next thing is that the classes can be deinitialized. So they have a deinit function which structs do not have. And the third thing is that classes support inheritance. A class can be inherited from some other class, for example UI view controller. When we create our own view controller, we are subclassing UI view controller. That is what inheritance is. This is something that structs are not having. Now let's move to the third type, that is actors. Now actors are very similar to the classes except one key difference, that is inheritance. So actors do not support inheritance but classes do. And if we talk about similarity, then both actors and classes are reference type. The other major difference between actors and classes is that actors automatically takes care of the concurrency related issue. That's the whole point of bringing actors. So actors were introduced in WWDC 21 and we can use them from iOS 15. And if you want to learn more about actors, that how they automatically manage the concurrency related issue and the multi-threading stuff, you can have a look at this video of mine that I did on handling concurrency using actors. Now let's move on to the frequently asked interview questions on classes and structs and little bit on actors. Let's start. We all know that structs are value type and classes are reference type. So that is not something that is worth asking. Now how interviewers tweak this concept in the form of question is that when structs contain a property of class type, its value will be copied or it will be referring to the same object. So if it is not clear to you, let's take this example that you are having a struct that is item, where you have a property total price that is of type double, so that is sorted, no issues with that. But the other property is text, and text is a user defined type, or I should say a reference type. So class has been used for making the entity text, and our struct that is item, it is having text as a property. Now when we assign one object to other and then change the values, what will happen to the value of this text? For example, I'm having two objects here, that is item 1 and item 2. Item 1 has been assigned to item 2 and then the values are being changed. So the total price and GST of item 2 has been changed and then we are printing the values in the logs. You can pause the video for a while and can predict the output. So what gets printed in the logs is that text for item 1 is also 15 and text for item 2 is also 15. This is because text was a reference type, and even when it was used inside a struct that is value type, its value was not copied, instead it was referring to the same object, same memory location. So that is the whole concept of reference type, because if it would have been copied, then we would have lost the entire concept of reference type. Let's move on to the second question, that is related to the copy on write. So we all know that structs are value type and value types are copied, but what will happen when the second line of this code will be executed? What I mean is that how many objects will be there in the memory when the second line will be executed. Now if you don't know the concept of copy and write, then it will appear that there will be two objects in the memory, because this is array and array is value type. So when value type is assigned to another object, then the objects get copied instead of pointing to the same memory location. But here in this case, because array2 has not been mutated till this point, there will be same object, they will be referring to the same object, or I should say that there will be only one object in the memory. As soon as we will make some operation on array2, the second copy will be created. And as a proof of this, you can have a look at my video that I did on copy on write, where I printed the address of both the objects, and you can see that both the objects are pointing to the same memory location, which essentially means that there's only one object, the second object has not been created yet. Let's move on to the next question. Memory allocations in structs versus classes. This is one of the very frequently asked questions on structs and classes, and it is a very conceptual one. That where does structs memory allocation happens, where it is done for classes, and how do they differ? Now most of you would be knowing that for struct it is done on stack and for classes it is done on heap. But let's see that how do they differ and why stack is used for structs and heap for classes. Let's see it in detail. So a stack is a data structure that works on the concept of LIFO, that is last in first out. So the object that is pushed last will be pulled out first. Now in terms of threads, each thread has its own stack, and the access to the stack which is associated to a thread, it is exclusive, and that is why it is thread safe. Now comes the point that why stack is used for value type. So in case of value type, the amount of memory that is to be allocated in the stack, it can be calculated at compile time. Now if someone asks you why for this, the obvious answer will be that value type does not support the dynamic memory allocation. And if the memory cannot be allocated dynamically, then we can always calculate it at the compile time. What makes it even faster is that allocation or deallocation can be done by the execution of one single instruction. So in a stack, whenever the memory allocation is to be done, the stack pointer will be moved to a point from where the memory is to be allotted. And when the deallocation will happen, the stack pointer will be moved back. This moving of the stack pointer up and down, this can be done by executing one single instruction, and hence the allocation or deallocation in case of a stack is really fast. Now let's see heap, which is used for classes or reference types. The first point behind the usage of heap is that heap is used in those cases where the calculation of memory cannot be done at the compile time. Now in case of reference type, the lifetime of an object cannot be judged, because same object can be referred, can be pointed by multiple instances. And to make this happen, the allocation should be done at a global space, so that it can be pointed from different locations. And the global space cannot be stack, because stacks are exclusive to each thread as we discussed. So that is why the memory allocation for the reference type is done in a heap, because that is in a global space and it is not exclusive to any particular thread. If we talk about the complexity of memory allocation and deallocation in heap, it is comparatively more than a stack. Because in a stack, we discussed that only a stack pointer is to be moved, which can be done through a single instruction. But in case of heap, entire heap is to be recalculated and it is comparatively tough to manage. So if we talk about the performance or the speed between heap and stack, stacks are faster, and that is because the cost involved, the time involved in the memory allocation and deallocation. Let's move on to the next question, which is generally a follow-up question after the discussion of stack and heap, and that is about memory allocation when a struct is a stored property in a class. So we know that the memory allocation for structs happen on stack and for classes it happens on heap. But how about having a struct as a stored property in a class? Where will the memory be allocated? And the answer for is this heap. Because even though a struct is a stored property in a class, but at the end of the day, it is a property of a class, and for the class, the allocation happens on the heap. And hence, the memory allocation for that particular struct will also happen on the heap. Continuing the same context, the next question can be, which one is thread safe? And by now, you should be able to answer this question because you know that how the memory allocation is happening for struct and classes. And the obvious answer is struct. Because for the struct, the memory allocation is happening on stack, and stack is having the exclusive access to the threads. So if shared access to that stack is not allowed, it is of course thread safe. And apart from struct, actors are also thread safe. Though actors are reference type, yet they are thread safe. Because that is the whole point, that is the whole purpose of actors, to handle the concurrency related issues. And this is done by keeping a track of mutable and non-mutable properties in an actor. For more details on this, I will again point out the same video of mine that I did on handling concurrency using actors. Let's move on to the next question, that is method dispatch by struct and class. So broadly speaking, there are two types of method dispatch, that is static and dynamic. Well, there are actually three types if we consider the table and message and all those. But for now, let's consider the two types of method dispatch, that is static and dynamic. And in case of struct or value type, the static dispatch is used, and for the reference type, the dynamic dispatch is used. I did a very detailed video on this in which I explained that why value type are using the static dispatch and why reference type are using the dynamic dispatch. Also, when we write the extensions to that, how the behavior changes. And this is just a screenshot of that video. So you can see that there's a table which is clearly mentioning the static and the dynamic dispatch in case of the initial declarations and the extensions. So if you want to know more about method dispatch, you can have a look at that video. Here's the link. Now let's move on to the next question, which is which of these will have a member-wise initializer? Now this is also one of the good questions which can have multiple follow-up questions. Let's look at this. So we have class, struct and actor, and the question is that which one has the member-wise initializer, or that is generally known as the default initializer. So the answer is struct. In case of struct, we get a default initializer which we call as member-wise initializer, but in case of class or actor, we do not get it. So if you see here, if I do not write initializer in struct, it works fine, but in case of class or actor, compiler gives an error that you need to write an initializer. So that is about the member-wise initializer between class, struct and actor. Now there's a follow-up question for this, that if a property of struct has been made private, how will the default initializer or the member-wise initializer work? So we saw that initializer was not needed in case of struct, but how about making the property as private? For example, here in this test struct, we are not having any private property, and hence we can directly use the initializer that is provided by struct. Now if we change this to private, that is if I make this some variable, if I change its access level to private, and then if I try accessing the default initializer, what will happen? You can pause the video for a while and give it a thought. So we will get an error if the property is private and we are not having any explicit initializer mentioned. So in this case, we will have to write an initializer and we'll have to deal with the initialization of whatever private property we have declared. Now another follow-up question to the same thing is that how can we have something similar to convenience initializer for the structs? So for classes, we have convenience initializer. We can call one initializer from other and can deal the initialization accordingly. But what if we want the same behavior in the struct? So if you do not understand that, what I mean to say here is that let's say we are having a test struct. I have a property, some variable in it, and in the initialization, I want a dictionary to be passed as a parameter, and then I will fetch the value, I will get the value from the dictionary, and then I want to call the self.init for initializing the variable that is some variable. I'll get an error that incorrect argument label because that is not the default initializer. If you didn't get it, pause the video and think it for a while. What I want here is that I want to initialize my property that is some variable by passing a dictionary and then calling the self initializer, the member-wise initializer that has been provided to me by struct itself. How can we do that? And the answer to that is by writing extension. So if I write an extension and write another initializer in that, then I can call whatever default initializer was there from the custom initializer that I just wrote. So this is also one of the good questions when the context is of initialization in structs and classes. The next question is that, is mutating keyword required for changing the properties of actors? To answer this, you should recall what we discussed about actors, that actors are very similar to classes. Now if they are very similar to classes, let's recall the behavior of classes. Do you need the mutating keyword with the classes? Well, actually no. So here I have a struct that is A, class that is B, and actor that is C. You can see that I am not getting the error for B and C. I am not getting error that I need to write the mutating keyword, but compiler is asking me to write mutating keyword in case of struct. This is because when self is passed to the functions of a struct, it is immutable. So whenever we try to change the value of any property of a struct, we get this error if we do not write the mutating keyword. But the answer to this question, in case of actors or classes, we do not need mutating keyword. Let's move on to the next question. Identity operator and its use. Now for those who do not know that what is identity operator, it is triple equal to. So for normal comparison, we use double equal to in case of integers or strings. But there's one more operator available to us that is triple equal to, and that is known as the identity operator. So it is double equal to versus triple equal to. And to elaborate this, we can say that equal to versus identical to. Let me explain this. So assume that we have a class phone and we are confirming to the protocol equatable because we want to provide the behavior, the criteria for comparing the two objects. So in case of integer or strings, we have the double equal to implemented. But in case of our custom structs or classes, we need to confirm to the protocol equatable and then override the method double equal to and then define the behavior that how do we want to compare two objects. So here I'm comparing the UDID of two objects, that is my two phones, for knowing that they are equal or not. Now let's try this. So if I take two objects of phone and provide the exact same value for the UDID and then I try printing that whether both the phones are equal or not using the operator double equal to, what will it print? And then I try the triple equal to operator, that is identity operator, and let's see that what it prints. So for the first print statement, it will print that both the phones are equal. Because we are comparing the UDID and we provided the same UDID to both the objects, and we defined the condition of equality that if the UDID matches, then they are equal. So we are getting the expected output here. Now in case of identity operator, it is saying that both phones are not identical. This is because in case of triple equal to, in case of identity operator, the reference of those two objects are being matched, it is being compared. And because those are two different objects, they are residing into different memory locations, the address of those two memory locations are not matching, and hence they are not equal. If I would have assigned phone 2 is equal to phone 1, if I would have wrote like phone 2 equal to phone 1, that is assignment of phone 1 equal to phone 2, then the identity operator, that is triple equal to, it would have returned identical. Because while defining my type phone, I use the keyword class. It is a reference type. So when I would have wrote phone 2 equal to phone 1, essentially they would have been pointing to the same memory location, and hence triple equal to operator would have returned identical. This is the difference between double equal to and triple equal to, and triple equal to is of great use in case of classes. When we want to compare the references, when we want to compare the objects, we can use triple equal to in case of classes. Let's move on to the next question. That is, when should you use class? Now this is the question that I intentionally kept towards the end of the video, because the questions that we discussed till this point, they gave you enough insight to answer this question. We are having enough knowledge for identifying the cases where we should use class. Now similar to this question, if interviewer asks you that where you should use struct, you can directly say that almost everywhere. So choosing struct can be a default approach, but choosing class will be very subjective to the use cases, to the constraints that we need to follow. Let's see that where we'll use class. And the first point comes is Objective-C interoperability. So if you need to deal with some code that is written in Objective-C, you will have to use class. This is because Objective-C was not having struct, it only had class. Everything was subclass from NS object. The topmost object was NS object. So everything was their class, everything was their reference type, and when you need to deal with that, when you need an interoperability with Objective-C and Swift, you will have to use class. So that is the first point. The next thing is that when copying doesn't make sense. So any value type goes for copying the value. And when you do not want the values to be copied intentionally, when you want to hold the same reference for different instances, then you should go for a class. The third point is very relatable with the second point, that is when we want a shared environment. When we want a shared mutable state, that I should be able to change the value from this point also, I should be able to change the value of the same variable from some other point too, then we will have to go for classes. And the classic example for this is app-delegate. If you see, app-delegate is also a class, and the way we access it is through the shared instance. So when you need the shared mutable state, you can go for class. The next point is controlling of the identity. As we just saw with the triple equal to operator, the identity operator, we can compare the references, we can compare the addresses of the memory locations. So when you need to control the identity of an object, when you need to compare the exact objects, when you need to go deep into the comparison, not just the values but the references too, so that is about controlling the identity, and in that case you will have to use classes. And the last point is that when you need inheritance. So this is the most important of all. When you need to inherit from one class to another, that superclass, subclass kind of behavior, then obviously class is an option. But here's a suggestion for this point. So in case of inheritance, most of the time it happens that most of the functionality that we are inheriting from our superclass, we actually don't need it. We rarely use all the functions. Instead, just for accessing one or two functions, we inherit the class. So if that is the case, and if you can solve it using the protocol oriented programming, if you can solve it using the protocols and extensions and those kind of things, go for it. Prefer the structs. They are faster and they are more efficient. Now let's move on to a couple of bonus questions. And the first one is reference type in Swift. So if someone asks you, if interviewer says that how many reference type are there in Swift, of course you will say class. So the class is first one. Then you will say closure. Closure is also reference type. And the third one is actors. So because actors are very new, they have been introduced in WWDC 21, we generally forget about actors. But if interviewers ask you for the reference type, even after mentioning classes and closures, then actor is something that they are expecting to hear. The next question is that what would you prefer for multi-threaded environment for dealing with the concurrency related things? And the obvious answer should be actors, because actors deal with all those stuff automatically. You do not need to write the code for dispatch barriers, for locks, semaphores, mutex and all those. Those are already handled by actors implicitly. But if actors are not the option for less than iOS 15, then classes are something that you will go for. because structs or value type do not provide the shared mutable access. And the third question is that structs don't support inheritance. How can you achieve something similar to inheritance with struct? So this is a kind of question which is generally asked to check the depth, that how deep can you think, how can you use the things which are already available to you for achieving something which is not available. And the answer for this kind of question would be using protocols and extensions by providing a default implementation to the functions of protocols. So of course structs are not having inheritance, but structs can conform to protocols and we can write extensions to the protocols. So if we provide a default implementation for any method mentioned in the protocol and then our struct conform to that protocol, we can achieve something similar to the inheritance. And if you want to know more about this inheritance and protocol thing, that how do they differ with each other or how they are relatable with each other, then here's a link to my video that I did on inheritance versus interface, in which I explained everything in detail. You can have a look. So that's pretty much for this video. A new video comes out every weekend, so you can consider subscribing to the channel. Let's write better code together. Happy coding and stay safe.